hotel in space. Wait, did they say there's going to be a movie theater?
The space station is going to be the first commercial space station with artificial gravity.
The world's first space hotel. It'll have gravity, full working kitchens, bars, and more.
I love the fact that in the marketing, they highlight this. They say, we'll have gravity, which is a really cool thing to hear. It's like it's a feature. It's a feature.
Are you guys going to be on? Are you guys going to be among the 100 people?
Now, please welcome your MC for the evening, Orbital Assembly Corporation's Director of Medical Research, Explorer, Aquanaut, Scientist Astronaut Candidate, Researcher, Physician and Public Speaker, Dr. Shauna Pandya.
Hello and welcome to First Assembly. As you've heard, my name is Dr. Shauna Pandya. I'm a physician, medical director of research at Orbital Assembly Corporation, and most importantly, I am your MC for today's event, and we are so thrilled to have you join us. We know that a lot of you have been a part of this community from the very start, and today, First Assembly is your event. We'll be sharing what we've been up to. You'll be hearing from our executive team, core team, advisors, and more. But most importantly, for those of you who have been waiting to join us on this journey, ready to invest, as of right now, by following this link to Net Capital, you can start to invest. For those of you who are following us online, we would love to hear your excitement of what we are up to. You can use the hashtag First Assembly. You can use the Twitter handle at Orbital Ops. And there's also the opportunity that some of you may have already followed. You can sign up to meet with our core team in Zoom breakout rooms at the end of this event at the top of the hour. Those links are available in the YouTube chat and at the bottom of the screen. Right now, it is my pleasure to introduce our CEO, commercial pilot with over 24 years experience, Mr. John Blinko. John, over to you.
Hello, everyone. Thank you for coming here today. You have been invited to our First Assembly event because you dream of a bigger future where large structures in space will be built, and not just a few, but lots of them. We're going to do that, but we need investment dollars to move forward with the engineering, fabrication, and testing of our first trust assembly machine as the ground demonstrator, the DSTAR. Later, we will build the flight version called the P-STAR, and that will build the gravity ring near the International Space Station. Those two projects will precede Voyager Space Station. First Assembly is about you, your chance to invest in Orbital Assembly Corporation, to become one of us, one of the owners of the first space construction company in history. How to do that? Click on the link in the description below to go to netcapital.com, where they have created an investors page just for you. Net Capital is a funding portal, and they're the pros of what they do. You can invest $1,000, $10,000, or $100,000, or just $100. But if you invest more than $1,000, we will invite you to the DSTAR debut when we invite the press and the VIPs to that historic event. We will also need your support and involvement in other areas such as advocacy, engineering, media, and more. This is your chance to help us move forward, to help us move up. This is a big deal. This will be the next industrial revolution. Back to you, Shauna.
Thank you, John, for kicking us off. Now it's time to meet the team that will get this project off the ground, literally. First off, it is my pleasure to introduce another one of our senior executives and co-founders to the stage. Please welcome our COO, CFO, VP of Business Administration, and VP of Habitat Design, a seasoned executive with over 20 years experience in the fields of business management, habitat design, architecture, engineering, and more, Mr. Tim Alatorre. Please take the stage. Mute.
Let's try that again, unmute it. I was saying thank you so much, everybody, for being here today. It has been a long road to get here, and it is fantastic to finally, after all these years of preparation, to make it. And we sent out an early invite to some of our ardent supporters a couple days ago, and the response has been overwhelming. And we are truly humbled by your faith in us and the investment dollars that are pouring in. It's going to make a huge, huge difference. And if you haven't already, go to netcapital.com. Like John said, any contribution helps, and you're going to become one of us. You're going to become one of the owners of Orbital Assembly Corporation. And your money that you're going to invest in us is going to be put to work immediately. You'll see later today, we've got a whole program planned out. We're going to talk to a lot of the engineers and designers and some of our advisors. They're going to go over the literal nuts and bolts of what we're up to. And you'll see what we're working on and where those money can really make a difference. And unfortunately, it's money makes the world go round. But like John said, we really need your help and your advocacy. And you're one of us. I remember when I was a kid, I used to sit on the couch and watch old, well, it's old now, but Star Trek with my dad. And we'd go to Edwards Air Force Base. And my grandpa, he's a retired Navy pilot. We'd go there and look at all the planes, and I'd see the space shuttle facilities there. And I had no doubt in my mind when I was younger that someday I would go to space and that Starship culture would just become a normal part of everyday life. And it's been 60 years now this April since Yuri Gagarin first left Earth and became the first human to orbit Earth. And in that time, we've learned a lot about how to live, work, and survive in space. But also, we really haven't seen that explosion of commercial activity in space. And there's two main reasons for that. The first one is launch costs. Since the 1960s, the cost to get a kilogram of payload into orbit has been about $8,000 a kilogram. And it's only recently, with SpaceX introducing fully reusable or almost fully reusable launch platforms and other companies who are coming and doing the same, that we're starting to see those prices fall. Right now with the Falcon 9 launch, you can launch about a kilogram to orbit for less than $2,000. And soon with Starship Heavy, I know we were all rooting for that Starship 9 launch to happen today, hopefully in the next couple of days, but as Starship comes online, it's going to be just a couple $100 for us to get mass into orbit. So that's barrier number one. The second major barrier why we haven't seen the public living for long periods of time in space has to do with the fact that microgravity is just brutal on our bodies. And Dr. Shauna Pandya, she's going to talk more about this later in the program about some of the medical effects and what we're doing to counteract that in the science research. But we need artificial gravity. We need a mechanism to allow us to have a dosage of gravity to be able to live long-term in space. And today you're going to meet only a small part of the team really who are going to make this happen. We have most of our board of directors on here and our advisors, like I mentioned, but in the opening video, you saw a lot of our DSTAR hardware that's under production. And we've had dozens of very talented engineers and programmers and automation specialists working with us to make paper turn into reality. And it's such an exciting time to be part of Orbital Assembly Corporation. And thank you so much for your support. We cannot overemphasize how much it means to us to have you be part of our team. And Shauna, back to you.
Thank you, Tim Alatorre. Starship culture, I got chills just hearing about that. For those of you who are making comments on social media, thank you. See them, and if you have questions, keep bringing them in. We'll get to them at the end. Now, from one Tim to another, it is my pleasure to call to the stage Mr. Tim Clement, our fabrication and assembly manager with over 20 years experience in manufacturing and senior management within the fields of shipbuilding, mining, and civil infrastructure. He also has experience setting up large-scale manufacturing on 3 continents. Tim Clements, take it away. Mute.
I got muted as well, so that's twice. Let's start again. Thank you, Shauna. Welcome everyone to First Assembly. It is my pleasure to introduce the DSTAR project, or Demonstrator Structural Truss Assembly Robot. This is Orbital Assembly's first real-life prototype, which is designed to create the structural backbone of future projects in space. This system has been engineered in-house by our amazing team, which consists of 3 loading magazines that house prefabricated truss sections and are transferred into an assembly area in order to make a fully assembled truss automatically. This machine is currently undergoing commissioning and shipping before final demonstration in our facility in California. And from there, we will record valuable data, lessons learned, and innovation ideas before building a full-size version that will be loaded into a launch vehicle fairing and launched into orbit. The prototype will produce a truss section that is 90 meters in length and under 90 minutes. The DSTAR weighs almost 8 tons in mass and consists of steel, electrical, and mechanical components. This is a super exciting time for Orbital Assembly, putting rubber to the road in our endeavor to make the Voyager Station a reality. Back to you, Shauna.
Thank you so much for that, Tim Clements. For those of you who are excited about what we're talking about, please feel free to tag us on social media using the hashtag #FirstAssembly. You can find us on our Twitter handle @OrbitalOps. And of course, if you're here to invest, follow this link at the bottom of the screen. Now it is my pleasure to turn it back to Tim Alatorre to take us through our Observer Drone project. Tim Alatorre.
Thanks, Shauna. Appreciate that. So Observer Drone is our first in-house drone project, and it is going to be really exciting. We've already started development of it, and it's become the backbone of all future projects. It's going to be our eyes on the job site. We plan for the first flight to be sometime in the next 12 to 18 months, but no longer than our first on-flight demonstration, which Tim just described, our P-STAR and Gravity Ring projects. The Observer Drone it operates in a support function. So we can use it in a variety of different configurations. It can perch on an existing craft. It can also be fully reusable. It can fly and have a free flight mode. And so it can do extended missions. It's going to be fitted with a suite of cameras and sensors, which will allow us to also fit a VR headset to where an operator of a construction machine can have a first-person view of what it's like to be there operating a system remotely. We see the Observer Drone being used for construction, commissioning, maintenance operations, and other tasks. And it's going to be, like I said, our first product that we're going to bring to market. And we really see other companies latching onto this key technology. Many of you I know watched when SpaceX launched their Falcon Heavy demonstrator, and they put Starman in the Tesla Roadster and launched it. And SpaceX got really creative with a boom and a camera that they had attached to the front of it to get a couple of really, really neat views of that with Earth in the background. But imagine how more spectacular that could have been had our Observer Drone been there, detached from the rocket and given us 360-degree views of Starman flying on the way to Mars. We see NASA and other space agencies and other private space companies really utilizing this technology to give them unprecedented access, visual and sensory data to their projects. So we're very excited about it. And Shauna, I'll pass it back to you.
Thank you for taking us through that, Tim Alatorre. Now I want to turn it over to OAC co-founder, Chief Visionary Officer, and Chief Scientist, Dr. Jeff Greenblatt. He has a PhD in chemistry with 20 years experience working in climate change, energy technologies, and space technologies. He founded the energy and space consultancy firm Emerging Futures and has worked at Lawrence Berkeley National Laboratory, Google, and NASA Ames Research Center. To take us through Gravity Ring, Dr. Jeff Greenblatt. Mute.
I was so ready. Hi, everybody. I'm really thrilled to tell you about the Gravity Ring project today. The Gravity Ring is going to be a key technology demonstration project that we plan to build, assemble, and operate in low Earth orbit in just a few years' time. And we're going to use an orbital version of the DSTAR that you've been hearing about, called the P-STAR, which stands for Prototype Structural Truss Assembly Robot. And what's really a big deal about this Gravity Ring is that it's a huge ring. It's going to measure 60 meters or nearly 200 feet in diameter. This is a 40% scale version of the Voyager Station's outer ring truss. And not only are we going to be able to build something this large in space, we're going to be able to make it spin in order to produce artificial gravity at up to Mars level. this is a necessary precursor before we build something as large as as large as Voyager Station. And the reason is we have all of these technical milestones that we have to be able to demonstrate so that we can build larger structures in space. So with the Gravity Ring project, which we expect to be able to build and launch within 2 to 3 years' time, although once it's in orbit, we will assemble it in an order of a few days. This will allow us to demonstrate the ability to construct things in space, and then once the station is assembled, to demonstrate orbit stabilization, orbit maintenance. We'll be able to spin it up and down several times and show that that goes well, and most importantly, provide stable levels of artificial gravity with a minimum of vibration or other unwanted effects. Now, besides being a technology demonstration, Gravity Ring can also be a research platform. And we're currently in discussions with several international space agencies and other entities about flying their payloads on the Gravity Ring. And why we want to do that is there are a lot of researchers who are interested in the effects of partial artificial gravity on both non-living and living systems. And being able to fly a payload on the Gravity Ring, which we're definitely designing the capability to do, will give researchers an unprecedented opportunity to access that intermediate gravity regime. So with the success of DSTAR and the Gravity Ring, this will then pave the way for OAC to build larger, more complex structures in space, which is obviously necessary if we're going to get to the point of building Voyager Station and other larger structures beyond. And just think about it, with these first few stepping stones, we are paving the way to a solar system-wide sustainable ecosystem built by humans and operated in a way that is environmentally responsible. So please join us on this journey. I look forward to your support and certainly to the investment that you might be making today. And now I'm going to turn things over to Tim Alatorre, who is going to talk about Voyager Station's habitation architecture design. Take it away, Tim.
Thanks, Jeff. Voyager Station is the project that got me excited about Orbital Assembly Corporation, and I'm sure you as well. Voyager Station is going to be our big station. It's going to have a capacity of 400 people on it. And I'm really excited about Gravity Ring, which Jeff just talked about, because that's a really near-term demonstrator where we're going to be showing a lot of the technologies that are going to be used to build upon and build Voyager Station. It's going to retire a lot of risk, and it's a direct analog. And you see here, Voyager Station, it's going to be 200 meters in diameter. It's going to have 24 habitation modules, and each module is 20 meters in length and 12 meters in diameter, which gives a great amount of space for a variety of functions. And also, since the station will be rotating, we're going to have near lunar gravity, which means that we're going to have the function of normal toilets and showers. You'll be able to walk, run, jump in normal yet unnatural ways. And the station will be comprised of a number of fixed modules, which will be used for any configuration of the station, including 2 that are dedicated to air, water, and power. We're going to have 2 modules, which will be a kitchen, restaurant, and bar module. Also, we're going to have a gym and activity module where we'll have concerts and sports events and other recreational activities. And the rest of the build out will be depending on our business partners and the market at the time. But we really are hoping that one of our first uses for Voyager Station will be for their hotel aspect. And we'll have hotel rooms, and we'll also have villas, crew quarters. We anticipate that government agencies will want to lease or buy some of the modules. And also government and other private companies will use the modules for training of crews headed for Mars and the moon and beyond, hopefully. And Voyager Station will become a platform for a variety of functions and business opportunities. And we really see that it will be a springboard for other entrepreneurs and businesses to build out a variety of space commerce and industry and tourism activities. So Voyager Station, we hope to have that in plan. Well, our roadmap, as we've laid out today, is DSTAR, which is wrapping up fabrication, going to the PSTAR, our flight hardware and Gravity Ring, and right into Voyager Station construction. And our goal is to have it all operational and first flights by the end of this decade. And I look forward to seeing you in the kitchen, in the restaurant there, and we'll sit down and have a drink and look out the window at the Earth rotating below us. So until then, Shauna, back to you.
Thank you so much for that, Tim Alatorre. One of my greatest hopes for Voyager Space Station is that we name our bar the Space Bar. Think about it. So there's a lot of good stuff going on with OAC. I hope you're as excited as we are, but if not, wait, there's more. It is now my pleasure to call to the stage our co-founder, CTO, VP of Engineering, and VP of Space Systems Architecture Design, Dr. Tom Spilker, a man with over 20 years experience as a scientist and engineer at JPL and heritage in NASA's Voyager, Cassini, Genesis, and ESA's Rosetta missions. Tom, take it away and take us through Voyager Space Station's systems architecture design.
Thank you, Shauna, and hello, everybody. After my work on NASA's Voyager, Cassini, and Genesis missions and ESA's Rosetta mission, it's been great working with this excellent OAC team and designing the architecture for Voyager Station space systems. Fundamentally, Voyager Station is a spacecraft, but one like no other before it. We don't want the Voyager experience to be like being in an attack submarine in combat, so we're architecting for comfort, especially for first-time tourists with no astronaut training. The Moon or Mars-level artificial gravity it offers allows the amenities that Tim described earlier. Using rotation to provide that artificial gravity without discomfort sets Voyager Station's size and rotation rate, 212 meters in diameter, about 700 feet, a bit smaller than the length of the U.S. Capitol building, and a nice slow 1 1/4 RPM rotation rate. We could have made it a lot smaller by making it spin a lot faster, but barf-lined floors and hallways kind of detract from the experience, so we went with big and slow. Much of the space system's architecture takes advantage of the fact that you're not on the ground, you're in space. So we designed in features such as airlocks at the base of elevator shafts, not just for maintenance access, but so visitors could don spacesuits and go for spacewalks. Imagine yourself in your suit, gazing out at the cosmos, with the helmet's faceplate being the only thing between you and the universe. Wow. But no matter why you're at Voyager Station, for research, for government or commercial activities, or just to be a space tourist, this architecture keeps your blood pumping and gives you reason to think, I'm really glad I'm here. Ad Astra. Back to you, Shauna.
Thank you so much for that, Tom. I cannot wait to also one day say, wow, thank goodness I'm here. So the next area that we're going to talk about is one that I'm arguably biased towards, one that is one of my favorites. I'm going to step into my medical director of research role right now and tell you about some of the potential for life sciences, physiology, and medical research that our platforms have to offer. So when we talk about the hazards of human spaceflight, we know that there is one potential showstopper, and that is an altered gravity environment. We have decades of data from human spaceflight that says that every single bodily system, whether we're talking about bone density loss, muscle atrophy, cardiovascular systems, fluid shifts, and even our nervous systems are affected by being in zero G. We know that the space adaptation neuroocular syndrome, which causes increased intracranial pressure and altered vision in certain astronaut populations, is a potential showstopper when we talk about exploration class missions and going to the Moon, Mars, and beyond. We also have questions about how EVA suits and their mobility will function in lunar gravity in that 1/6 environment. We have lots of data in 0G. We have lots of data in 1G. But what about the in-between? In a seminal 2017 paper from Nature called Artificial Gravity, the major space agencies got together and created a roadmap of questions to answer that artificial gravity platforms could offer, including the duration of artificial gravity exposure, the dose, how the human body fares in Martian gravity, identifying potentially deleterious effects on the human body to artificial gravity rotating systems, and finally, validation in space. With all of the platforms that we've put forward today, we offer solutions to these questions in a place as convenient as low Earth orbit. And we very much look forward to collaborating with the academic, research, and commercial sectors to answer these questions and more. But let's take a step back and look at the bigger picture. We are gaining momentum at OAC on a lot of fronts, from research to engineering and more. So finally, as we wind up today, it is my pleasure to call upon OAC's Chief Business Officer and co-founder, James Wolfe. James is an entrepreneur and attorney with multiple areas of expertise, including business, finance, real estate, investment, and intellectual property. His corporate portfolio includes co-founded companies such as Deep Space Industries, immortal data, space initiatives, and united space structures. James.
I am excited to join with our team today and to announce the launch of our capital raise. And I encourage you to visit our partners at Net Capital to learn more about this opportunity. We are at the cutting edge of the space construction industry. We have designed and patented a revolutionary space construction machine that we've named the Structural Truss Assembly Robot, STAR. The STAR is a game changer. Our terrestrial variable geometry truss demonstration system, DSTAR, will demonstrate the fastest truss assembly capability in the world. Then, we will embark upon the development and launch of the P-STAR, our first commercial machine in orbit, which will serve as an early market demonstrator for commercial in-space assembly. But that is not why I find this project so exciting. It is the potential applications, the potential markets our company can enter, made possible by the development of the STAR. I predicted this years ago at the formation of OAC that we would one day develop a customer queue for the STAR analogous to traditional linear 3D printing system queues. It was this prediction which has guided our business development planning and bestowed keen insight into our strategic ROI initiatives. I see this prediction is now coming to fruition. We have our first customer agreements in principle executed with companies like Mankin Space Technology, Inc., the space-based solar power satellite company founded by Dr. John Mankins, our Arecibo Space Telescope Replacement Project, our Voyager Propellant Depot Project, our Mars Colonial Habitat Ring Project, an extension of Voyager's potential, and more. Your investment will help us make these amazing projects a reality and allow us to develop, build, and launch the construction machines that will one day serve our customers. We believe that we are well positioned to execute our carefully constructed business development roadmap as I have just described. Because you are a friend and a supporter, we would like to offer you the chance to participate in this opportunity before we go to the institutional and strategic investors. Pursuant to the terms listed in our investment documents and agreements, you will be able to invest in our current round, being priced at 25 cents per share. There are no investment maximums, although consideration must be given to your investment objectives, risk tolerance, and ability to hold an illiquid investment. Your investment will allow us to complete the development of DSTAR, P-STAR, and our first STAR construction machine, and of course, Voyager Station, and the many customer projects that are now in our queue. Thank you, and ad astra. Shauna, back to you.
Thank you so much for that, James. As you can all see, big things are afoot at OAC, and we are excited about the future. And judging from your comments coming in from our channels, you are as well. I know we may be a little bit biased, so now I want to call upon some of OAC's key advisors and community members to share their excitement and hopes for our projects. I now invite Jeff Grayson, Rhonda Stevenson, and John Mankins to the stage. First, I want to turn it over to Jeff Grayson, who may be no stranger to most of you. He is founder and CEO of XCore Aerospace. He was instrumental in the development of the U.S. regulatory regime for commercial space and served on NASA's Augustine Commission for Human Spaceflight, which recommended the Commercial Crew Program. And of course, he's now currently the chief technologist at Electric Sky, his power beaming company. Jeff Grayson, over to you.
There are really many applications for large truss-like structures in space. They would be useful for propellant tank farms, which is a badly needed technology for both government and private missions. They would be useful as supports for large antenna arrays, which is the core technology both for transmitting power and high bandwidth communications down to Earth, and for astronomical observations of space. But certainly the application that has me the most excited is that this could finally open the way to doing the critical test that we've needed for 50 years on how do you keep human beings happy and comfortable and healthy for long periods of time in space. That requires some level of artificial spin gravity. We don't know how much, we don't know how fast, we don't know what radius of rotation, and the only way to get that information is to try it. And OAC's technology offers a pathway to doing those validated experiments in the near term affordably, and I found that incredibly exciting.
Thank you so much, Jeff Grayson. Now I'd like to turn it over to Ms. Rhonda Stevenson, who some of you know very well as a Space Industry Development Executive Strategist. She continues on as the President and CEO of the Tau Zero Foundation, Director of Public Affairs with the Kepler Space Institute, as well as founder of Blue Elysium Enterprises, a space entrepreneurial consultancy firm, and of course, strategic advisor to Orbital Assembly. Rhonda.
Hello, I'm Rhonda Stevenson. Thank you for joining us today. We are excited to share this opportunity with you. Orbital Assembly Corporation is making space accessible to everyone. We're leading the charge of industrial development of space and increasing humanity's access further out into the space ecosystem. The steps you take with us today create crucial infrastructure to enable more businesses and individuals just like you to participate in the growing space economy. By taking these steps together, you join the ranks of space pioneers, explorers, and entrepreneurs, making the statement, space is now open for everyone. Thank you for your support today, and we'll see you up there.
Thank you so much for that, Rhonda. Last but not least, it is my absolute pleasure to call John C. Mankins to the stage. He is president of Artemis Innovation Management Solutions, LLC, president of Mankind Space Technology Incorporated, and a director of Solar Space Technologies. You may also know him as the vice president of the Moon Village Association, as well as his role as a board member for the National Space Society and Space Canada, as well as dean and professor of the faculty of the online Kepler Space Institute. John.
Thank you so much, Shauna. It is a great pleasure to be here today speaking to all of you about the accomplishments and the goals of Orbital Assembly Corporation. The outlook for the exploration and utilization has been transformed by several recent developments. First, the advent of low-cost space transportation. Second, the production of low-cost space hardware, which has been proven through the emergence of new space markets such as mega constellations in low Earth orbit. Yet another important opportunity exists: the concept of harvesting carbon zero energy in space and delivering it safely and affordably to markets across the world. Such developments, however, will depend upon the capability to assemble quickly and simply very large structural systems in space. For example, using wireless power transmission, solar power satellites might deliver many tens of thousands of megawatts of carbon-free energy globally. Just one such platform could power thousands of homes. However, sunlight is relatively diffuse, fortunately for life here on Earth, with less than 1.5 kilowatts per square meter in Earth orbit. As a result, the structures comprising a single solar power satellite would have to be enormous, spanning thousands of meters. The need for sustainable space solar power is enormous. Delivering that power would not be limited to a single construction job or even a dozen, but rather would involve hundreds of projects over decades. Whether the satellites delivering green energy to Earth, or artificial gravity space hotels, or vehicles to travel across our solar system, the ability to build really large structures affordably in space will be essential. Fortunately, this crucial capability for the future is already being established today by Orbital Assembly Corporation. Back to you, Shauna.
Thank you to John and to all of our advisors, Jeff, Rhonda, for sharing your enthusiasm and your vision for OAC's future and potential in transforming commercial space. Last of all, we're incredibly grateful to you, our community, who've been with us since the beginning, we know are excited to get going with us on this journey. To share a few final parting words, John, you kicked us off. I invite you to come back to the stage and send us off. John Blinko.
Thank you, Shauna. For those of you who have already invested today or yesterday, thank you. We have been getting a lot of reservations. Next week, Net Capital, the funding portal that we are using, is going to go live with this investment opportunity to their large base of investors. And when they do, this round could close fast. So how long you have to invest is not certain, but today is. Don't miss this chance. Invest soon. Invest today if you can. We have with us today a representative from Net Capital. His name is Eric Cox, and he will answer any questions you have about using their funding portal. Remember, in a few years, when you have friends over some evening, you can point up at the sky and say, see that white dot that's traversing the sky? I own some of that. We look forward to you joining our effort as owners alongside us as we build large structures in space and transform this era into the age of rotating spaceports. Back to you, Shauna.
Thank you so much. So for those of us who are following along on social media, on our various channels on YouTube, I'm sure you are burning with questions, ideas, comments. The rest of the time at First Assembly belongs to you. For those of you who have signed up ahead of time to join us in our private breakout rooms, we'll be starting at the top of the hour. But for now, we've been watching the chat. I invite the rest of the team to come on up and we're going to start fielding your questions. So let's get to them. All right, so first question. Will Gravity Ring be incorporated into the future Voyager Station or will it remain a separate project? This comes via Facebook from John Spady.
Cool, I guess that's for me. Yeah, so Voyager, Gravity Ring is a technology demonstration project. So it could have a life of several years in space if we have additional funding from NASA or other space agencies or even private entities who want to do long-term partial gravity experiments. But it's basically meant to show that we can build large structures in space. And at some point, its life will end. And we will then launch another larger, more sophisticated construction machine, the STAR, in order to build Voyager Station. Also, the Gravity Ring is only a 40% scale version of the Gravity Ring of the Voyager Station outer ring truss, and so we can't use it in that context. But it will be a really important technology milestone, and it could have a life beyond its demonstration, depending on how our partnership pursuits go.
Great, thank you. I see a comment from our friends over at SpaceWorks. John Old says they're developing modular connector nodes for in-space assembly of large structures and platforms. Good luck, we should talk. John, we encourage you to reach out to us at info@orbitalassembly.com. We would be happy to talk to you further. I'm seeing a lot more questions come in. So the next question comes from Isaac Bates. He says, will we be using a type of monopropellant to spin the station up or down or something like a reaction wheel?
That's a Tom question.
I think so.
I'm not sure if you heard it. Oh, he dropped off.
I could answer that though.
Yeah, go ahead.
Yeah, so it hasn't been decided yet, but we will probably be using exactly what the propellant mix will be. But it will probably be a monopropellant as opposed to a reaction wheel because we're going to need a lot of angular momentum change for this system as well as for orbit stabilization. So that's the direction we're going.
Yeah, and I could just add to that the reaction wheels are good for maintaining orientation, but they saturate quickly. So if we're spinning it up, we would not be able to maintain the clean rotation as we go. So that's where we would use a rocket motor.
And I guess I can also add that we're on a pathway toward designing our propellant systems to be refillable so that, because we want to be up here for a long time. And so since we're going to have so many visits to the station, we'll be able to top off those propellant tanks periodically and essentially have an infinite life as a result.
Tom, did you want to add anything to that? Did you hear that?
I couldn't hear it because StreamYard kicked me off, but I did want to add something to what Jeff said about using the gravity ring for Voyager Station. The main thing is the gravity ring is a 40% scale model of Voyager Station, and so it's not big enough to be a part of Voyager Station.
Thanks.
Perfect. So we have two questions that I'm going to pair together. They have to relate to crew training. So Nick Vanderpeers asks, have we already started a civil multidisciplinary crew for exploring space? And then Stephen Nancaro asks, how are people being trained to work in space? Are they being trained now, or is that path being planned out now? So who wants to take that on?
I'll take that one. Crew training for deep space exploration is not our thing, but we will be training crews for space construction, not for gravity ring. That is going to be a completely automated construction. But when it comes time for us to start building Voyager Station, then we will launch OCC Alpha, which is the command center for the construction. And that's going to have about 6 or 8 people on board, and they will be building the station with both robotics and astronauts and the machines, of course, that we use for construction. But we're probably going to be not training them ourselves. We're going to be looking to NASA and other space agencies for a crew who have space time with experience doing this kind of thing. Now, as they're up there longer, we're going to have other people trained down here, our own people, who are going to replace them over time. But you can't bypass that kind of talent when it's right there, ready to go. I've met quite a few astronauts, and they're excited about this project. So we will utilize that talent.
Perfect. So Isaac Spade come back with another technical question. He's asking how people will walk from the docking ring in the center to the outer rings while gravity would be increasing the entire time.
Yeah, I can take that one. So if you look at the renderings, there's 4 elevator shafts coming off of the docking ring. So when you're in the center of the station, you're not experiencing really any noticeable gravity. I mean, it's all artificial, right? But the forces that are pulling you outwards. And you'll have an elevator that you'll get into. And so that elevator, as you're extending out towards the outer ring of the station, you would be feeling those forces start to pull on you. But we would have harnesses or grab bars. And as you're going down, you would start to feel yourself being pulled to the floor. And then as you get to the outer ring, then you'll be able to walk normally.
Perfect. I have a few questions coming in relating to the next generation. So a couple of questions, I'll pair them together. John Spady asks, what are STEM classes or other directions that a student in middle school should now be considering to have the opportunity to work in space? There was another comment, not sure who it came from, but asking, will there be opportunities for students to participate in internships? So who wants to field that one?
We have a lot of doctors on this call.
Yeah, I'll take the first part of that. STEM is extremely important because we're going to hire a lot of engineers as we move forward to be building not just a Voyager Station and other things, but all kinds of constructs in space. But keep in mind, we're not just hiring engineers to go up there and work. There's going to be technicians who have a strong technical background, but there's going to be everyday people up there too. Well, of course, you too, Shauna, because we're going to need doctors up there. We're going to need a bartender up there. We're going to need cooks up there. We're going to need people from every walk of life as we start to serve the people that come up there to spend that time in space. So there's lots of disciplines you could get yourself trained in to get a chance to go up to Voyager Station. But the early construction, yeah, that's going to be a lot of engineering.
Yeah, I think just looking at this call, we come from a variety of backgrounds. So Tom and Jeff, they come from more engineering backgrounds. I come from an architecture and a business background. John comes from a flight and an aviation background. Tim, he comes from a manufacturing and a machining background. Eric's our resident financial expert here today. So there's, like John's saying, do what you're passionate about, and there'll be opportunities for you.
Yeah, I couldn't agree more. There's going to be so many opportunities for people to contribute to this project, both now and certainly down the line as our projects and our funding increases. And so to also answer the question about internships, while we're not really in a position to offer anything yet, I think that is definitely coming. And so we're going to need all the help we can get. And often some of the best ideas are contributed by young people with fresh ideas. So yeah, please get in touch.
Perfect. Oh, wow. Our questions are blowing up. So if you've already asked a question or two, we're going to give preference to folks who haven't asked yet. I see a question asking about the orbit parameters. This comes from Steven Siwak from Facebook. What are the orbit parameters? Will we be in a common orbit offset from the ISS, or how close to the ISS?
I could take that also. I think the question is referring to gravity ring, but I'll also answer it for Voyager Station. So gravity ring, we plan to put in a co-orbital with ISS that would either be ahead of it or trailing it. And the reason for that is it's a place where a lot of spaceships go. And more importantly, we have an ability for ISS to lend some kind of support should something go wrong. There's also be eyes and ears, so to speak, monitoring it. We could get some great TV footage from a distant vantage point as well. And so for that demonstration, we plan to fly with ISS. But for the larger Voyager station, we're probably going to be in a different orbit. ISS has to be boosted a lot in order to maintain its orbit, and also passes in and out of the sun's light. And so it creates a lot of thermal stress as well as intermediate power that has to be dealt with. So ideally, Voyager Station would be in a polar sun synchronous orbit where it'd be getting sunlight 24/7, would have a very stable power and thermal environment. But other options are also possible, and we certainly haven't ruled them out.
Yeah, and I'll just tack on there about Voyager Station. We have designed it to be in that sun synchronous orbit. And if you look at the renderings and the designs, one side of the station has all of the shielding and the solar panels. The other side has all of the viewports and the openings. And so we're designing it, and the radiators. So we're designing it to where we don't have to articulate the solar panels and the radiators several times a day like they do on ISS. The station itself can maintain orientation to the sun, and it really simplifies the engineering and maintenance of the station.
Perfect. So now there's a couple of questions. Go ahead. Yes.
Having the station with one side towards the sun all the time.
Oh no!
Oh,
Tom's having a really hard time with his internet today.
Yeah.
All right. You know, we wanted to have this event live. I think there's a lot of events we wanted to have live, but it didn't work out.
Yeah.
All right. So I'm gonna forge on ahead. If Tom comes back, we'll certainly loop him back in. I'm going to continue on with a few questions related to hiring. People are asking when we'll be hiring. If we're hiring engineers, they know an engineer, me, referring to themselves. So hiring, when and how will that happen?
We're going to start hiring pretty soon. That's one of the reasons that we're getting together this money, is so that we can fill out our engineering departments and production departments, so that we can move forward with these projects that we're talking about, the DSTAR and the PSTAR. So yes, hiring is going to be happening quite soon.
And I would say, I was going to say how to find out about that. So John's also president of the Gateway Foundation, and so the crew membership over there. We already have a lot of contact information from people who've supported us, you know, from even before Orbital Assembly Corporation was a company. And so definitely we'll be looking at those people. The investors who've been reserving over the last couple of days, they've been putting in their information. So we'll look at them. And then also just go to orbitalassembly.com. We'll have job listings posted there.
Perfect. So someone wants to know if SpaceX is one of our partners. They saw a picture of the SpaceX Starship, so they were just wondering what is the status of that?
We cannot call SpaceX our partner, but in the future, we look forward to working with them because they are one of the large launch providers out there that we can utilize. And of course, Starship is, it's the big kid in the block. So when you want to launch some heavy equipment into space, that's your best bet. But we don't have a contract with them yet, but let's just say hang tight.
Perfect. All right, so here's a question that I think we all know the answer to. How can someone buy shares if they are interested? Who wants to take that one?
Eric,
can I say one or two things on this? Yes. So I wanted to actually flashback for a quick second. Love the question about the next generation. That warmed my heart. And I did love seeing another lawyer on the call about lawyers in space. How cool was that? how to invest. The easiest way is to go directly to the link at the bottom of this. That's netcapital.com/companies/orbital-assembly. If that's too much, don't worry about it. You can go directly to netcapital.com, click the invest button, and then you can search by name. And so just search Orbital Assembly. It's in reservation mode right now, so you can reserve the opportunity to invest, but that does effectively put you in line to invest in this company. So you can go in there and start investing right now, and that's the easiest way.
Perfect. There's a question here that says, what is the total assembly cost of the orbital gateway? I think that's referring to Voyager Station.
The total cost for Voyager Station, that's a lot of that's depending on launch costs, and that's been coming down, so it's not easy to nail down that exact number. However, in our prospectus, we outlined a very detailed breakdown of what it would be, and I'm going to let you go ahead and talk about that, Jeff, because you're involved with that, about that breakdown.
Sure. Well, I would say it's still preliminary. There's a lot of things that we have not gotten to the point where the engineering is finalized to be able to put a price tag on. And as you know, in the space business, a lot of things will change over time. But we do have confidence that because we're approaching this in a very modular fashion, that we'll be able to realize fabrication, and assembly costs that will be a lot lower than historical. So as John was saying, depending on launch costs, it could be on the low end, but we are definitely looking in the tens of billions of dollars for the full construction of this station. And I'll just leave it at there because it's still a bit speculative at this point.
All right, so we're going to pair a couple of similar questions now. Joe Kozak and someone else asked about what kind of mod will we be using, rigid or flexible members in the ring instead of the habitat modules as the rigid members? And this also pairs with another question that says, I assume the modules are inflatable in order to fit in a Starship as they couldn't be fit or launched as rigid designs, or they think it means there will be flex from the rotation and you'll have to use rigid walkways or swing out panels. So commenting on the flexibility versus rigid design, who wants to take that one?
I'll take that. Indeed, we are going with rigid modules, and no, they wouldn't fit in a standard Starship or New Armstrong fairing, but there are ways to get them up there without even having those fairings. So we're working on that, and it looks like we have viable means of doing that to get up those rigid structures. The ring itself, the outer ring truss, as we call it, will indeed be a rigid structure, but just like any bridge or building here on Earth, you call it rigid, but it's not truly rigid. It can flex a little bit, it can move a little bit, and we have a system by which we can control that. We've got a dynamic spoke network, and we've got mass distribution control that we can use to control the stresses on that truss. It may move a little bit, but not much. So it's not rigid, but it's rigid enough.
Perfect. All right, 8 more minutes, lots of questions. Let's get through as many as we can. Simon Robertson asks, how do we check the quality of the structure welding in order to hold 1 atmospheric pressure?
Tom,
yeah, Tim, you want to take that one?
Who want to answer?
Yeah, go for it, Tim.
I think that was coupled with another question as well about how do we maintain certain welding methods in space. There's a various number of applications that we can apply, and trying to use prefabricated sections and couplings and various other items to eliminate that work in space as much as possible. But there are friction stir welding methods and other methods that will be autonomously produced. And cameras that will be on the heads themselves, so we can monitor quality and things like that. But the aim is to reduce the amount as much as possible. Tom, you can add in some more there.
Yeah, indeed. Operations in space are a lot more expensive than operations here on the ground. And so we're trying to do as much of the assembly as we can here on the ground, including welding and so on. And especially the entire modules will be.
Someone
Let's
pick
go
that
again.
up. Anticipate what he was saying.
I think what he was going to say is the entire module will be prefabricated on the Earth.
Right.
And so we're not going to be welding those. And same thing with the truss sections, which you'll see at our DSTAR demonstrator event later this spring. We're using a combination of prefabricated sections and automated, assembly processes.
Right.
Okay. So we now have a question on how much gravity will gravity ring generate, and will it be constant at every time, or are gravity variations expected?
All right, so I'll take that one. And just again, Gravity Ring is a technology demonstration project, and so it's not designed for humans to be walking around on. And indeed, it will be variable because we're going to be testing its performance at various levels. We're currently engineering it to be able to withstand up to Mars level gravity, which is 0.38 G, or about 3/8 of Earth gravity. We'll be operating it for a fair amount of the time in lunar gravity also, because that's currently the design spec for the Voyager Station, although that's not final. And there might be some reasons why we actually want to spin Voyager at up to Mars level gravity for instance, if there's a lot of interest in Mars true Mars crew training. But the short answer is that there'll be a variable amount of gravity that will be tested, as well as induced vibrations and other things, which basically put gravity through its paces and make sure that it doesn't shake itself apart. So
we have a question that kind of falls within my domain. Alec Landau from Facebook asks, what effects will the Coriolis force have on items and people in the station? And so this is one of the areas and the gaps to be addressed in the artificial gravity roadmap that's been laid out by NASA, ESA, and more. And so we have some data from the 60s wherein they had subjects spend about 12 days in a room rotating at 10 RPM. But what they noticed is that the subjects didn't carry out all the tasks that they were supposed to, presumably because they felt motion sick. But there is some data saying that when subjects were spun up in a progressive manner, that they seemed to acclimatize more quickly. And that there was also a lot of gaps with respect to a lot of physiological performance and behavioral parameters that they would have liked to study. They wanted to know the effects on the central nervous system, on the cardiovascular system. So there's a lot of gaps to be addressed, but that is part of the international roadmap that's been identified by the major space agencies. All right, plugging away at questions. Maybe we have time for one last one.
And we just had Jeff Grayson join us. I'm not sure if we have a question for him, or Jeff, do you want to add something else from your comments earlier?
No, I'm glad you're talking about artificial gravity. That's where it's at. But I think I said most of what I had to say in the prepared remarks.
Perfect. All right. So I see we started off talking about your opportunity to invest. So let's end with a question about the opportunity to invest. Larry Miller asks, is $100 the minimum investment that Net Capital accepts, or can I invest $50? Eric, do you want to take that one?
I'm happy to. Yes, technically $99 is the minimum investment amount, and so that's kind of that's where it's set. And you can go into reserve and click invest, and that'll be the minimum investment amount, $99.
Perfect. Thank you so much. So in the 90 seconds left to us, I'm going to wrap it up. I'm not going to leave you hanging. I know there were so many questions out there. So we're at the end of our first assembly event already, but honestly, this is just the beginning. If you are excited about what we have told you about that we're working on today, please go down to Net Capital. Please invest. Please join our journey. This is our first assembly. This is the beginning of our plan to make space more accessible and to revolutionize space construction and the space economy. Please, please, please reach out to us at info@orbitalassembly.com, or you can reach out to us on Twitter @orbitalops. If you had a great time at this event, if you had a figurative blast, please let us know using the hashtag #FirstAssembly. And you can always find out more about opportunities at our website, www.orbitalassembly.com. You can find all of these links. They're being flashed across the screen. They're at the bottom of our YouTube channel. And for those of you who have signed up to meet with us privately, we are heading over to the break room now. For those of us who have enjoyed the event, please feel free and enjoy this wrap-up video. And for our key community members, our VIPs, and our investors, we look forward to seeing you at our DSTAR event later this year. Ad Astra.